Thank you so much for the introduction. Hello, everyone. Good afternoon. Yeah, Suadi Tukon. Is that correct? I'm not sure. That's the first word that I learned in this country. Yeah, this is my first time in Thailand, in Bangkok. It's really good experience for this, and this fan is also amazing. Okay, so yeah, uh, in here, I will gonna talk about something about the security rules, and then about unit testing, and then about the pipeline integration. But first of all, let me introduce myself. My name is Pradana, and I'm from Indonesia, especially from Jakarta. And yeah, currently I'm the newest GDE for the Firebase, last 22 in September. And I am also working as an engineering manager in Bukalapak. It's one of the e-commerce in Indonesia. Okay, so let's fire this up, Fanny. Maybe just get to know each other. Currently, I was joining university in 2015, and then I was being a DC lead. Maybe you already familiar with that. And then about the mentor for the Guru Kajar and GDG in Jakarta. So currently, I'm switching from the organizer of GD Jakarta into a GD Firebase. So yeah, that's pretty quite adventure. So if you have any question, feel free to reach me out, and yeah, I'll try to help. Okay, so right now, I want to talk about these three things. As we know that actually we got these three sensitive resources. I'm sure most of us are already aware about what is these logos, like a real-time database, Firestore, and storage. Uh, and actually, these sensitive resources can be protected with the security rules, as we can see from the picture. But actually, what security rules can protect? Actually, it can protect from anonymous or maybe any anonymous access from any people, or maybe even from the admin itself, or even from the developer itself. So security rules is really, really useful because it can protect our sensitive resources from these actor, basically. Okay, so, but the question is, what kind of protection that the security rules can protect? So yeah, the first of all, from the anonymous side, in Firebase, we already have some pre-built public and private key to prevent anomaly access. So which means that you don't have to build that from the scratch, but it's already built on top of that. So it will protect your sensitive resources from any malicious attacks or everything. And it's also, yeah, like what I said before, is protect from the malicious attacks. And the second one, from the admin side, uh, basically, security rules can also protect our sensitive resources by preventing from the admin to update the wrong record accidentally, for example, because we are people, and then sometimes you got some mistakes as well. And sometimes we also can protect about when the admin updating the data, or maybe they are doing some fraud. So that's might be really comes such an issue. So in that case, we can protect it with the security rules as well. The third case, maybe the admin account got hacked. Okay, that it got breached. Maybe it got some social engineering or hacking, and then yeah, it's really dangerous as well. There are a lot of actually was it some gap or maybe some trick that we can get in to get the sensitive data from our resources. And from the developer side, we can also prevent bugs by protecting the code payload consistency. Because sometimes we didn't have a consistent payload whenever we hit our resources, and then sometimes it got bugs. Or maybe it got some middle people, or maybe got hijacked by other person malicious attack, and then the payload is kind of different, and then your apps will be behaving some kind of different. So that's might be really dangerous as well. So how about how the protecting about the payload consistency? For example, in here, as you know that we can protect with, we can only allows member to write member ID, but only if the operation has the UID. So this is one of the protection that it can provide, because if the request doesn't provide the UID, it means that, yeah, it will be rejected from our server. This is really useful because sometimes maybe we forget about the consistency of the payload, and then it throw some bugs that we didn't realize. Yeah, that's one of the example. And then the second example is that we can also prevent bugs when the developer maybe forgot about the specific rule in some user flow journey. Maybe so that we can see in here, for example, we in the Firestore on the collection members and members ID, we only allow write if we have this some special condition. So this code actually also help us, the developer, to remind that actually there is some special condition in here. So in that case, we have some function, and then this function have some special condition, for example, and you can just return some special condition in here. So yeah, I'm sure that our project maybe gets more complicated, get more complex along time, and maybe like your rules will be like a 100 rules or maybe yeah. But this one might be really helps if you can wrap that into function and into a readable function. And as a developer, of course, we will be reminded whenever we try to make some code changes from the rules. Okay, so the third is about we can increase the code quality, of course, by using the strong and centralized data flow and its operation. So, for example, in here, you can basically centralize all the rules that you have. For example, you allow write for this collection in particular, and you allow read for this collection in particular. So basically, you can centralize all these rules so that we will have the same format, we will have the same behavior, and of course, when we are trying to onboard new people, it will get easier as well. Okay. So now the question is actually, is that protection is enough? Technically, yes, because we have all of this security. We already prepared for everything, but actually operationally it's not yet ready. Can you guess what? First, there is some story. Let me introduce you some of my friends in this slide. This is we can call this as Pira Chan. Hello, he is a new fresh graduate engineer. Cool. And then Mr. Dart, senior software engineer. Nice to meet you. And yeah, it's just some background stuff, their childhood, and we are got the same tech and interest. And Pira Chan asking that actually. So operationally, nope. What might be missing, I wonder. What might be missing? And then Mr. Dart answered, well, the factor is actually human error. So no matter how really great our security or maybe the technical everything, but if we still have this human error factor, then yeah, it still be really dangerous. So there's always a threat. In that case, oh yeah, I remember. I think I had those mistakes. Yeah, since Perchan is a new fresh kit engineer and makes some mistakes, and I think that's quite normal. It is the first thing is that oh no, I have a product demonstration in a minute. I need to rush and finish this code. Oh, Perchan is on fire right now, and then oh my, it breaks my old code. I didn't realize it. This is the first actually case. The second case, all right, easy task. Let's get home. It's already done. Really easy. Oh, it breaks my old code as well. I didn't realize it. And then the third one, okay, I concentrated and not underestimate the code changes already. Everything looks fine. The human error already minimalized. And then, oh no, it breaks my code. The library has changed the implementation. And I didn't realize it again. So yeah, all this mistake basically comes from the human error. So see, because of those, it's actually it might causing us, like for example, money loss, data breach, or maybe some anomaly data that we, yeah, it's really as dangerous especially for the company. We can sometimes also losing a lot of money as well just from this simple mistake. Okay, so sorry, it's okay. Learning is really important, and that's how we are people, of course. So let me tell you something. Actually, at least there are these three levels. The technical one, the reg one, and then the testing level, and then the automation level. Basically, whenever we build the security rules, building the security is correct, technically amazing, but how about the testing the security itself? And then once we have this testing for the security, how about the execution of the testing? So it's kind of like there's some a level and a level and how to make sure that there is no gap or maybe some threat for our product. In that case, we should minimize the human error by building this auto and testing. Okay, cool. So in that case, what we can do is actually, first one, we should build our testing for security rules. And then once we have that, the second one, we can automate the running security rules testing. The last but not least, we can protect the branch with the automation. So basically, the automation will handle everything to protect and minimize the human error. Okay, interesting. Okay, cool. So now I will show you some demonstration. I hope it's fine. All right, I will show you how. The first of all, assuming that actually we already have this Firebase project initiated, and yep, and then we can also do some Firebase init. And assuming that in Firebase initialization, we initialize the Firestore, and then initialize the emulator. Okay. So the emulator, I only use Firestore because in this particular demonstration, I only put the security tools for the Firestore. All right, so we have this setup enabled. So before we jump into our Firestore rules, which is still blank, of course, it's better we planning to do some TDD or test-driven development. Maybe we can start from the testing itself. So we can make some further tests in here, and then make some test files, security rules tests. And for example, first thing first, we can import the library for the testing. The library comes from this library at Firebase/rules unit testing. Okay, we got the unit testing, the library to test our security rules, and then we can mention about the project ID, and then yeah, basically we just importing stuff. And then the second one, we can try to initialize the test environment for our Firebase. So basically this test will be happens on the local, so that to make sure that it runs well on the local host. You can define the host and the port of the Firestore that you put on the Firebase.json before. And then we initialize the Firestore, make some function so it's reusable on each test. And we can also, before each, we try to initialize the Firebase by basically get Firebase. Okay, cool. So let's try to make some tests about the members. So in this case, we are having some members and we are having some admin to handle the members. We can try, for example, you should be able to see member profile data. In this case, we use the unauthenticated context in here. Unauthenticated context means that it is not logged in. And then we try to see if we can see this collection members/user ID. And we try to get doc and make sure that we succeed. We will run the test later on at the same time to make things faster. So I just wanted to explain this one by one first. The second one, you should not be able to write member data. For example, as a member or as a user that is not logged in, we can't try to write any data in the user ID, of course. This is the second test case. Again, we can continue in the third one. If the user is logged in authenticated, then we can write the data. Assert succeed in here. And we can go the next one again. We can put a lot of other context, depends on what we need, basically. So this is really great so that we can protect our product really well. So because everything will be technically protected in this test case. I think we can just skip some. And then this is a lot of tests. The next one, I want to try to build a test for the admin itself. You should be able to write or update members if the role is admin. So I added the context into the admin. I'm usually basically using admin ID. And then we can assign some destination for the collection to write the data or update and assert succeed if we can update the data. This is basically just our test case for basically everything. Okay, So we have these test cases. And now let's try to build the Firestore rules. Okay, we got these blank rules. If we run the test, of course, it failed, of course. But let's try to build one, which I already prepared for some. Maybe you can make some function to make things easier, but I will explain that later. The point is that in here is, with all of these test cases, we only need some these rules, just like some small lines, some lines, and then it means that we allow read the data if the request authentication UID, user ID, is equal with the member ID. This means that it's only the user itself can read the data. Other user can't read the data. So this is a good validation because it prevents other user ID can read actually data that actually not from the user itself. And then we allow write if admin has permission to write in the database, basically. In this case, I make some function, and if the user ID that is requesting, which is admin ID, is in this particular collection in get database documents admins has permission, this is collection, and then the data privilege, which means basically in these collections, it will have some admin's ID, which means that only this admin's ID can perform some write, and that's the acknowledged admin, basically. Okay. So now we got this. When we run the test, this one, it will fail because we didn't run any Firestore basically instances. So what we should do, of course, we hit some Firestore instances as well. In here, I prepared some things first. First thing first, we can try to run the Firebase emulator by Firebase Emulator Start. It will run Firestore in our local. So you don't have to use the production version, but you can use the local version that is not affecting the production. And I prepared some import data here, emulators data. Okay, to make things fast so that we don't have to seed the data from start. And when we try to hit the Firebase Emulator Start, as you know in here, we can try to open this one and see. Maybe I should zoom in. This is the seeding that I did. Basically, I have members and member ID, and then user ID, some email, and admins. Collection has permission, and there is some write field, and then it has array of admin ID. So basically, I can put all of these admin ID in here. So basically, all of the admin ID that is written on this particular collection has a permission to make things easier. Okay, so that's wrap about these Firebase emulators, and then we try to run the test. So it's pretty fast. Yeah, it's already fast for all. As you can see in here, it's run all the test case in here. You should be able to see members data. If it's denied, then it will be permission denied, like what it says in here, permission denied. Cool. So we got all of these passing data. But yeah, this is kind of too long. Most likely, maybe we can try to kill this first. And actually, you can, if you don't need to open the UI of the Firebase emulator, you can also do something like Firebase emulator exec. This means that you only fire up emulators only to execute some commands. For example, in here, I only use this Firebase emulator to run the test, npm run test on the end of this. So this is kind of similar, but it is automated. So whenever you run this command, and then it will run the Firebase emulator, it will run the npm run test, and it will shut down the emulators after that. So basically, it's really good resources that is quite fast, and you don't have to do manually. Okay, we have all of these things works. Cool. Now, let's jump into the automation. We already succeed about the build the security rules, and let's jump into the automation. I'm sure that most of us have used GitHub Actions. Maybe basically GitHub Actions can use to be for a pipeline for our repository to run something, and yeah, we can. It depends on our use cases. So in that case, I have these workflows in the GitHub Action. So in this case, I name these actions run all unit tests using Firebase emulator on push, which means whenever I push into some branch in this particular pattern, which is story, and then star means that all the story will be run on this pipeline. And then the first step, I basically try to check Kids Firebase Emulator if exists. This is to make things faster so that you don't have to download the emulators every time the pipeline is running. And then the second one, we use some Node, of course, since this is on the website, on the Node. And then we install the Firebase tools, of course. We need Firebase tools to run the emulators. So basically, we will run the emulator inside the pipeline. And then we try to install the dependencies, if any, if we need it. Then the last but not least, we run the test with the imported data. So I run the test in here by mentioning the local one. Maybe there's some question in here, right? Have you realized it? It's actually still echo. It's just echo, like it's not doing anything actually. Echo npm install GPG Firebase tools. It's just printing the text. Echo npm install because I already make some compilation and build the Firebase tools on this repository, which is in here, Firebase tools, to make things faster so that we don't have to download the Firebase tools, and we also have the node modules as well. Okay, so that's it. We already have this, and maybe from the GitHub side, I already made some PR, security rules test pipeline. And in order to protect your branch, of course, we need to setting the branch first. For example, in the settings, and then we try to go to the branches, and then we have these branches protection rules. We can set up this. For example, we try to make some branch protection rules, and we name the referee, for example, production. So these production branch will be protected. So the first thing I usually check is basically a pull request before matching. So this will prevent the developer to push directly into the branch. So it's only accepting the pull request. And then the second one, if the developer uses a pull request, the pipeline will be run, and it requires some status checks on this emulator unit testing push, for example. And then the last but not least, don't allow bypassing the above settings means that administrator will also apply the same rules, basically. Because if you don't check this, the admin still can push the code directly and ignoring everything. I think that's kind of dangerous. So in this case, I'm also don't believe the admin itself. So we can do some save change here, and then once the changes has been saved, you can go back to pull request in here, and maybe we try to make something some changes, for example, just adding new line, I think, and then we try to make some changes, not important commit, and then we try to push that. So whenever we try to push that, the pipeline will be run. So we can't merge this one. It's still disabled, and we check on the details. The pipeline is actually running. As you know, this is emulator unit testing push, and basically this is still waiting for the instances of the GitHub version to pick up the job for the pipeline. Maybe I need to, oh, it's already. So if you check in here, the details actually running all these checklists for the pipeline. It's really fast, right? Like it's not even, if you check in here, it only took like 13 seconds to run everything. Because I prepared for this demonstration to make things locally and using caching technique to make things faster. Of course, it will be good for developer as well. I will try to explain this one by one. So yeah, and here, for example, basically the default GitHub actions. We set up the job, run actions, checkout. And in here, I put some Firebase emulator if exists. Basically, I already run this pipeline before, so this caching the Firebase emulator, so it will not fetch the Firebase emulator again, which is to make things faster. And then we can run actions. Node setup is basically to set up the node. And then we need to install the Firebase tools. In here, I just printing some Firebase tools because basically Firebase tools already installed, or not installed basically, already located on the project. This one, Firebase tools, and is already compiled. So in the action, I just need to define the directory Firebase tools like bin firebase.js. This is the bin or the executable. So yep. Uh, In here, Firebase tools, and we install dependencies if necessary. And yeah, in here, the most important thing is that in here, run test with imported data. In here, I run the test basically. I hit fire up the emulators and seeing the data that I already put on the pipeline. Basically, it's checking all the test cases and 10 passing. It's all pass. So script executed successfully. And then after the pipeline finish, the emulators will be shut down automatically to save memory, of course. So this is a really good one. After that, post cage and then post runs and complete the job. So the job is completed, and then when we run into the pull request again, the time that actually we can't hit the merge button right now is all checks have passed, and we can merge the pull request. So in summary, actually, this pipeline and all of these checks, we already covers all the three levels, basically, from the technical, and then from the testing, and then from the automation. All of this is required to reduce the human error from the developer, from the admin, and from the admin also. Okay, I think that's all from me. I hope it's really useful for all of you guys. Thank you so much, and good afternoon.